Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called G Officer Kropki by Alchemist. It's a reference to a song in West Side Story. Um, I don't really know it that well, but so I'm not gonna sing it for you because I don't really know I don't know it too well, but I know that it's a popular song. Um, Talking about delinquents and stuff. But here we have delinquent Kropki dots here, I guess. And did I say this was by the Alchemist? By Alchemist? Anyways, this is by Alchemist. Then let's get to the actual rules. We have chaos construction rules, where we need to divide the grid into 9 orthogonally connected regions so that each row, column, and region contains all the digits 1 through 9 without repetition. So this could be an example of a valid orthogonally connected region because you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. This is not a valid orthogonally connected region because to get from this cell to any other cell in the region, you would have to go through a corner or would have to go outside the region through edges, which is not allowed. So that's an example of how chaos construction rules work. We also have extra chaos, where no 2x2 square anywhere in the grid may be entirely part of the same region. So know if you have 3 cells in a region in a 2x2 area, the 4th cell in that region cannot be the part of that same region. That's all it really is, right? So say we had 3 cells here, which are all part of the same region in the 2x2 box. This has to be a different region. So that's what the extra chaos means. And we have Kropki dots, where black Kropki dots separate digits that are in a 1:2 ratio. White Kropki dots separate consecutive digits. And both digits on a black or a white dot must count the number of cells they see orthogonally in the same region as themselves, including themselves. Interesting. So as an example, say this was a 3 here. That would force this to be a 6 to be, actually, let's not do that. Let's do 4. If this is 4, this would have to be 3 or 5 to be consecutive with it. So that's the normal white Kropki dot rule. This would have to be 2 or 8 to be in a 1:2 ratio with the 4. So that satisfies the normal Kropki dot rule set. I'm getting a little clogged, so I'm going to take a cough drop to try to clear my sinuses. But anyways, both digits on a black or a white dot must count the number of cells they see orthogonally in the same regions as themselves. And it includes themselves. Interesting. So this must see 4 cells of the same region orthogonally. And I assume it's being blocked by any digits that are... Yeah, they're blocked by any digits, I'm assuming, which are not part of its region. So it could see 4 cells here. And then I guess it would be blocked by these cells. I'm assuming that works. This would have to see 8 cells in the same region. So obviously this wouldn't really work, but... or if this were 2, it would see only 2 cells in the same region, right? But basically, both digits that are next to a black or a white dot counts the total number of cells in the same region that they see, including its own cell. So it includes itself. I hope that was clear. So that's for every black and white digits next to every black and white pair. Okay. We have also Kropki whats, where gray Kropki dots separate digits in a 1-to-2 ratio and or consecutive digits, but you must determine which for each dot. And any digit on a gray dot may, but need not, count the number of cells they see orthogonally in the same way as black or white dots. So there's no guarantee on here that they count the number of cells. They could, but they don't have to. So those are Kropki what dots. And then we have Kropki nots, where cells not next to a Kropki dot never count the number of cells that they see orthogonally in the same way as black or white dots. So say you had like a 4 here in the corner. This would have to count it could never count the exact number of cells it sees in its own region, right? So this would not be valid as 4 cells here going that way. That would not be allowed. Interesting. And that's for every cell in the region that is not next to a Kropki dot, which is gray, black, or white, right? So again, the grays could count them. The black and white the cells next to black and white dots must count them. And the cells that are not next to either a gray, black, or white Kropki dot cannot count the correct number of exact cells in the same region that it sees. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's mark the full boundary of the grid. So we know 1 can never be next to a black or white Kropki dot. And the reason is every cell, since all the cells in a region are orthogonally connected, every cell has to see at least 2 other cells in its region, guaranteed. So if it's next to a black or a white dot, it can never be 1. So these have to be 2, 3, 4, 6, or 8. These are 2, 3, 4, 6, or 8, interestingly enough. These are 2, 3, 4, 6, 8. 2, 3, 4, 6, 8, and 2, 3, 4, 6, 8. Interesting. What does that mean? Okay. This can't be 8 in the corner. If it's 8, that would mean it's next to 4 and 4. The 8 would have to see 8 cells in its region. The problem is, if it includes both 4s, then it would see 4 cells this way, because this can only see at most 4 cells this way. This would see 4 cells that way, and that would see only 7 cells, which is not allowed. If it tried to see 8 cells all in one direction, obviously, then this cell would also see those 8 cells and would never be correct. So 8 can never be there. What about 6? 6 has a similar problem, I think, right? 6 forces this to be 3 and 3. This would have to see either 6 all in the same row or column, which doesn't work. Because then this would see 6 in the same row, and therefore would not match its correct digit. Or it would be seeing both, but then this could only see 3 and this could only see 3. That would mean this sees 5 at most, which is not allowed. So this cannot be 6. Can it be 4, 2, and 2? No. So this can never be double one of these cells. Okay. So these could be double of these cells. And because of that, so say this is 2, then this sees 4, right? One of these is going to have to be blocked off. The other one has to be going a certain direction. You cannot have 4 and 8. Because if you have 4... Actually, you could. Never mind. Oh, but that's interesting. Because then... That's interesting. How does this section work then? So no matter what, one of these goes like extends essentially all the way here, or like so. Say these two are part of the same region. This must extend this way to complete, because it can't extend this way because this is in 1:2 ratio, right? And this has to be part of a set of one of these two. That means this cell is also part of a set with one of these two also. Okay. So how does that work? So say you have this as 2 and 4. Well, you could have 4. Oh, you could have 2 here. You just can't have 6, 3, and 3 or something like that. You could have 4, 8, and 2, and that could work. No, that doesn't work. So say you had 4, 8, and 2, right? The 4 cannot be seeing the direction of the 2, right? If it tried to go that way, it would only see 2 cells at most this way. So it has to guarantee going this way. So you see 4 going that way, therefore this is a different set. The problem is this has to see 8 cells total. It sees only 4 cells here. Then it would be 5, 6, 7, 8. And this would be more than 2 then, which doesn't work. So yes, this cannot be 2 here. So these are, again, double of what that digit is. But the problem is, whichever way this goes, this must contain both of these digits in the same region. So this cannot be, again, double of what these are. Right? So say it goes like this way or whatever. And then this goes this way. This has to be double of what this cell is. So that means you have to have whatever amount is here has to go here. So these are guaranteed to be part of the same region. These cannot be... Well, yeah, these cannot be because of the same problem that runs into here, right? Or is that the case? Um... Okay, let's try 4 and 8. That's always going to be interesting. So then this has to be 8, which means this is all the same region. This sees 8, so this sees 4. So that would see there. So this would have to see 4 this way. And then that doesn't work because these are not going to be in a 1 to 2 ratio. This can only see 5 here, if that's the case. So that's not going to work. And that works. That's the problem either way, right? This would see 5. This would have to only see 4. This would have to see 4 this way and another 4 that way. But this would be 5 in total that these would see. So 4 and 8 does not work. What about 2 and 4? I think that could work. Yeah, you could have 3 and 6. Yes, that could work. What about 3 and 6 this way? If these are 3 and 6. So you have 3 going this way. 6 obviously going this way. This would see 3. That could work. You would have 4 and 8 then here. Okay. Okay, so we're guaranteed this is either 2, 4 or it's 3, 6. Either way, that would eliminate 3 and 4 in the rest of column. We're guaranteed one of these is 3 or 4. One of these has to be 3 or 4, right? 4 is with 2 or 8. 3 is with 6 here. So that eliminates 3 and 4 guaranteed in the rest of column 1. So we have 1, 2, 5 through 9. 1, 2, 5 through 9. That's interesting. So this, if it had 4 here, It could go there. That could be the possibly. Okay, let's try 3 and 6 though. I'm guessing, well, I don't know. If we go 3, 6 here, then this would have to see 6 cells this way. And then these would guarantee to both see at least 6 cells in this direction, which is not allowed. Because then this would be 8 and 8 at minimum, which is obviously not a 1-to-2 ratio. So if it's 3 and 6, it has to go 3 and 6 this way. This sees 6 cells that way. This sees 6 cells here. So that's 3 here, and then another 3 this way. So these would have to see at minimum 4. So one of these would be 4, and the other one would have to be 8. Well, that doesn't work, because if you have 4 and 8, the problem is we already have 3 cells here. And the 8 here sees only one of those 3 cells in that region. You can only have 9 at most in a region. So 9 minus... It sees 1, which means it misses 2. So 9 minus 2 is 7 cells that it would necessarily see. So this cannot be 3 and 6. So this has to be a 2-4 pair. So this is 2, 4, and 4, guaranteed. That means this cannot be 2 and 4. This becomes a 3-6 pair here. So therefore, no 2 and 6 in the rest of column 1. This cannot be 2 and 4. So no 4 in these cells. No 2 and 8. This must be a 3-6 pair. This can't be 4 or 3, 6. So this is 2 or 8, which forces this to be a 4 here, to be in a 1-to-2 ratio with a 2 or 8. Can this ever be the larger of the two? No. If this is 6, that would force both of these to be 3. And whichever way it went, right? 2, 4, 6, and 3. 2, 4, 2, 4, 6, and 3. If this were 6. So say it went this way, right? This would obviously see 4 cells this way. And we tried to have 6 here. The problem is with 6 being here is that these only see 3 cells. So then this would have to see another 3 cells this way. But then this would be 3, seeing more than 3 cells. So I think this has to be 3 here, and these are 6. So either way, whichever way you go, it would stop here, 2, 4, 3, 6, and then would have to continue on like this. So we know this is the same, this is red region. If it goes this way, it can't be going this way. It has to go that way. So this has to be red, if that's the case, right? So if we go 2, 4, it sees 2 this direction. This sees 4 total, so it would be 4 this way. This would then see 3 completely. This would have to see 6. It sees 1, 2, 3, 4, 5, 6. And it's the same either way, right? Okay. 4 is consecutive with 3 or 5. Interesting. These digits are consecutive with 2, 3, 4, 6, or 8. So this cannot be 1 again. If it's 2, this has to be 3. If this is 3, this is 2 or cannot be 4. If this is 4, this is 3 or 5. If this is 6, this is 5 or 7. If this is 8, this is 7 or 9. Unlikely to be 9, but could be. So this digit is never going to be, cannot have 2, 3, 4, or 6. So this is 1, 5, 7, 8, 9. Hmm. 1, 2, 3. Oh, that's interesting. How does that work? So say it went this way, right? Obviously, this would go up. So this would be 4. Then this would have to be 6. That seems like it works fine. This has to see 6. So therefore, it'd be part of the same region as this. Right? Because it only sees 1 cell this way. It has to be at least 5 cells this way. The problem is then this would have to see at least 8, right? So say it saw 6 cells this way. I guess that's possible. Then it would have to be 2 cells that way. This would see 4 cells in this direction. Oh, it could be 4 cells that, including that. So this is at least 6 cells, 7, 8. It would have to be 7, 8, so this would definitely be part of the same region. Since this would be all yellow, this would have to be a different region. So this would have to see 4 in this direction. So it'd see either 3 here in that one, or 3 here in this one. But if it saw 3 here in this one, the problem is there's no 2x2 area that has the entire region. So if it was yellow here, this would cut off yellow here. And therefore this would have to be yellow. This would only be 1, 2, 3, 4, 5, 6, 7 cells. So you could only do 8 and 9 here, and therefore these would all be yellow. So yellow could not be here. Yellow would have to be 4 that way. Therefore, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, that's possible. Interesting. So far, it's possible. Dang it, I was hoping that it wouldn't be. What happens if we go the other way? Okay. This would be red. This would be yellow. This would have to see 6. Oh. How would that work? So this would be at least 5. How would this work? This is 3 or 6. These would have to be the same region. How could this see 3? It can't. Because it sees at most 2 this way. It has to go either 1 this way, but then that would be a 2 by 2. That's all the same region. Or it would have to go 1 this way, which means all of these would be a 2 by 2 region. So then these cannot be the same region as this, but then it must be 3 going this way or 6 going this way. And then the problem is they're not part of this region. So they're a separate region, and therefore they will only see each other's exact amounts. So therefore this cannot go this way, so we've proven that. So it has to go the other way. So it actually has to go this way. So we go this way, this sees 4. So this is done as a region here. This is done as a region here. This sees 3, that's done as a region here. This sees 6 here. So this is done as a region here. So this has to be 6 this way. It must be part of some sort of yellow. 5 at least going this way. This can't be 8. This can't be 2, so this is 8. This has to be part of this region. So we know this is like some sort of blue thing here. This sees 1, 2, so this must see 6 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't work. Oh, right. It cannot. This is the full 8 here, so this can't be blue. This is yellow. So this is the full yellow region here. 1, 2, 3, 4, 5, 6 it sees. 1, 2, 3, 4, 5, 6, 7, 8 it sees. So this is done as a region. This is done as a region. Right. This sees 4, and then it stops as a region. So this must see at least 6. So this sees 6, this sees 3. Therefore, it sees 2 more greens here. This cannot be green because this 2 by 2 area has 3 greens. So it's another region, cannot be red because red stops here because it sees only 4. So this must be some sort of pink, which must exit out. Since the pink must exit out, the red has to exit out as 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done. The pink must exit out that way to form a region of 9. So the red's done. The pink exits out. The green, we don't know what's going on here. This is a separate region. It sees 3 at most. It cannot go 3 this way because that would block the green, so this has to be at least 2 cells here. It could be pink. No, it can't be pink. 1, 2, 3, 4. Yeah, this is at least... One of these is at least green. These digits have to be 1, 5, 7, 8, 9. So we need 2 as one of these digits. Remaining digits in yellow are 1, 2, 3, 5, 7, 9. Obviously, 2 cannot be here. 3 can't be here because of 2s and 3s in the row. These digits are consecutive, and or in a 1 to 2 ratio. To be consecutive or in a 1 to 2 ratio, you have to have at least 1 even digit. We already have 4, 6, and 8 accounted for in this row. The only even digit then is a 2. And it can be in a 1 to 2 ratio with 1, or consecutive only with 1 because we can't have a 3 here. So this must be a 1 to 2 pair, which eliminates 1 and 2 in the rest of the row. So this is 5, 7, 9. Can this ever be 3 cells this way? The answer to that is no. If it's not part of blue, therefore the blue would only have 8 cells in as a region, which is not allowed. It has to have 9. So it can't go 3 that way if it's not blue. If it is blue, 3 going this way, the problem is this would form a set of 9 that way, but then these 2 cells would not have a region. So whatever region this is, it cannot be blue. Actually, it could be blue. 1, 2, 3, 4. Yeah, that could be blue. We're going to mark it as orange for now. But it's probably blue, actually, to make it work. Okay. These cannot see 5. These cannot be 5 because they would see 5 cells. So this has to be a 7-9 pair, which eliminates 7-9 in the rest of the region and the rest of the box. Or, sorry, the region or the rest of the row. This can't be 7 or 9, so this is 5. This would see 6 cells. Okay. Interesting. So all 3 of these have to see this, like, okay. Obviously, this can't be 9. There's no way this could be 9. Say that, okay, let's try it. 9, 8, and 4, right? If this is 9, it would have to see all 9 cells. This would have to be part of it. So these would have to be part of the same region. Could not be part of blue. So this would be some other region. Yeah, it just doesn't work, right? You would have to see 1 cell this way or this way. Could not be this way, so it would be here, and then the blue would be cut off. So yeah, 9 does not work. What about 7? 7 and 8 is a little bit problematic. I don't even know if 7 works. Okay, so 7 would have to necessarily be part of this region. Right? You can't have it seeing 7 cells without including this cell. So this is part of the same region, therefore they can't be part of orange. So this is obviously 6 or 8, which makes this a 3-4 pair there. If it sees 7 here, it cannot be part of blue, because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cells in the blue region. So it has to necessarily include all of these. If we tried to close off 7 going this way, that fails. 1, 2, 3, 4. It's because then this would be 1, 2, 3, 4, 5, 6, 7, 8 as a region, which is too small. So cannot close off that way. If we try closing that way, then I guess we could. No, we can't close off this way. This is too large as a region. This would then have to be 8 that it sees, and then for it close off there, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, but then all of these would be a blue region, which is not allowed. So yeah, 7 doesn't work either. So this can't be 7. Which means this cannot be 8 here. What about 5? 5 potentially could work because it could be part of the blue. If this is 5, this is 3. Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this wouldn't see 5 cells. So if it tried to connect to orange and... Okay, so I don't think this can ever connect to orange and blue. If it tried to connect to orange and blue, the problem is you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 cells already. This would only see 4 cells, which is not allowed. So yeah, it cannot connect both of these. Interesting. So these are separate regions. Okay. So what happens if we just make this 5 then? Then that makes this 3. Orange could be... Okay, so... Say this was part of the orange region then. If that was part of the orange region, this would be done. This couldn't be a 2x2 region for there. We know we can't connect to the blue because that would be too small. So this would see 1, 2, 3, 4 cells, which is not allowed. So it cannot be part of the orange region, which means the orange region goes there. This sees 5. And we have a problem here, right? If it goes 5 and goes there, so saying it's part of the blue, it cannot go full 5 here because this 3 is done with this, and it has to cut in one of these spots, which is not allowed because of the 5. So if we tried not going that way and giving us space there and going this way, this 5 cannot be part of another region, right? So then say it's not blue. So say it's not blue, then this, again, has to be the full 5 here, and it blocks off the orange region, which only sees 3 cells. So this cannot be 5 either, which makes this 2 and 3, which is only consecutive with 2, 3, and 4. This obviously can't be 3, but you have 2, 4, 2, 4 possibly there. Okay. So we're guaranteed one of these is a 3. That's interesting. These could be the same region as long as they're basically not part of the orange region. Hmm. This could be 3 and 5. 3, 5. Obviously, this could only see 3 at most, so therefore it would have to include there. Can it be 2? It's kind of a question, right? So say this was 2, that would force this to be 1, that to be 2. This would have to be 3, this would be 6. So the 2 would have to go either this way, or this way. So it wouldn't be... Okay, you can't have blue going all the way around here to here. Okay. Can't... What happens if this is 3? So the thing is, can this ever be blue here? I think the answer to that is no now, right? 2, it obviously connects more than 2 that way. So if we have to go to there, then this is all blue, but then this cell can't be orthogonally connected to another region. So that doesn't work there. If we tried to have 3, it could be 3 that way. 1, 2, 3, but then it's stuck, right? It would be 1, 2, 3, 4, 5, 6, 7. You can't see any more cells this way, so none of those can be. And then you'd have 8 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9, but then this 2 by 2 area is all blue. So if this is trying to be 3, it could be 3 potentially like this way. 1, 2, but then the problem is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just doesn't work. So this can never be blue. Interesting. So where does the blue have to go through? The blue has to go, cannot go this way. We tried multiple ways. We tried 5. Can't be 4, can't be 6. We tried 5, we tried 7. Obviously 7 can't work with the blue. 5 doesn't work with the blue. So this can never be blue. How does the blue get out? 1, 2, 3, 4, 5, 6, 7, 8. It has to go that way. It cannot be all blue here. Therefore, these are part of the same region. So the blue has to go out that way. And this is done. So therefore, this is done as a region here. Because we already have 9. Therefore, it sees 4 here. This is 4 that's consecutive, or that's in a 1 to 2 ratio with 2. Which is consecutive with 3, and that's 5. 2 eliminates 2 here. This is 1, which makes this 2. 5 must see, this must see 3, and it cannot be part of this region. Because if it's just part of this region, the problem is this sees 2, and that doesn't work. So this must be part of this orange region. This must be orange then. This sees 3. This is done as a region, so it has to see 3, 1, 2, 3, 4, 5. So that's all part of the same region. This is going up. So we have a boundary there. This then has to be 2. Which eliminates, and this can't be 5 because there's no 5 in, we already have a 5 in the row. So this is a boundary here. This goes 1, okay, so it could go like that. So this sees 3, this sees 5, this sees 2, and then it's done. So, okay, so that's boundary. So this has to go this way. This is a separate region. So it's boundary that way. It must continue on there. these 3 cells cannot be in these cells here, so they must be exactly those cells, so this must be 5. This cannot be 2 or 5 anymore in the yellow region because of the 2, 5 in the region. This is a 1, 3 pair. Okay. Remaining digits in the blue region are 1, 3, 6, 7, 8, 9. No 1, 3 here, or 8 because of the 1, 3 pair in the column and the 8. No 1, 3 here. Remaining digits in orange are 2, 4, 6, 7, 8, 9. This can't be 2 or 4 because of 2 or 4, and these can't be 2 because of 2 in the column. This can't be 2 or 4 because of 2 or 4 in the row. Remaining digits in column 6. We have 2, 5, 6, 7, 9. Okay. No 6 here because of 6 in the row. 4 is in a 1 to 2 ratio with 2 or 8, but cannot be 2 here. So it could be 8, could be consecutive with 5. 7 consecutive with 6 or 8, so this could be 8. 8's consecutive with 7 or 9, and 9's consecutive with 8. Remaining digits in column 9. 1, 3, 6, 7, 8, 9. No 6 here, obviously, because of 6 in the row. No 3 here because of 3 in the row. Okay. Remaining digits in column 2. 1, 2, 5, 7, 8, 9. No 2 here because of 2 in the row. Where is the 6 in this blue region? If it's any of these cells, it sees exactly 6 cells. So the 6 has to be here to be in the blue region, because then it sees 9 cells instead of the 6 that it cannot see because it's not next to a Kropki dot, either gray, black, or white. So that eliminates 6 in the rest of column 9. Interesting. Could this ever be 8 is kind of the question, right? I think probably no. If it's 8, it's guaranteed we have 8 cells this way. Well, that's not true. It could be some cells this way. This cannot be 4. If this is 4, it would... Oh, it's next to a Kropki dot. Never mind. Okay. Remaining digits of row 6 are 1, 3, 5, 6, 7, 8, 9. No 5 or 6 here because of 5 or 6 in the column. Yeah, I'm trying to avoid this because I know this is going to be hairy going through all the possibilities. It was already pretty hairy going through these possibilities. Hmm. Remaining digits in column. Oh, this could be 4 here. Because it could be a 1 to 2 ratio with 8, right? Hmm. Okay, remaining digits in column 8 are 4 through 9. Orange needs access to a 2. If orange only went this way, so it was not part of this, it'd be 1, 2, 3, 4, 5, 6, 7, 8. Cannot go that way. It would be 9. Can't go that way. And it would not have access to a 2. So the orange has to go this way, period. 1, 2, 3, 4, 5, 6, 7. It could go that way still. Hmm. So this cannot be the same as pink, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then green still doesn't even have 9 cells. So this has to be a separate region. Therefore, this must be a separate region. Can it ever be pink this way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No. Can't be green. That would block the light region. So this is guaranteed to be not light because this only sees 3 cells at most. And if it tried to go around, this cell would not have a region. So this has to be different region. Cannot be dark gray. Can't be orange. Can't be pink. Can't be green. This kind of has to be medium. I mean, I guess it could go like that. Just none of them can reach, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So dark can only go 5, 6, 7, 8, 9. So dark can only reach to here. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Orange can go 1, 2, 3, 4, 5, 6, 7. Only 2 more. So 2 more here, 2 more here. So 1, 2, 3, 4, 5, 6, 7 guaranteed, 8, 9. So this cannot... I think this has to be orange, really. Interesting. Orange can go to here. That's it. Pink can go up to here. We have 4 more cells for pink. It cannot get to here. You could go here. So 1, 2, 3, 4, 5. You cannot block off medium. You can't block off light. Interesting. So we have 1, 2. So you cannot block off 2 set regions here. So these could be, this can never get up to here because it would block off 2 regions. With the light and the medium here. So we have 1, 2, 3, 4, 5. This could be pink. This could be pink. So 1, 2, 3, 4, 5, 6, 7, 8, 9 potentially. That could potentially be pink also. So that's the boundary of pink. Light cannot go to here. So green has to be in one of these. At least one. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have a 9th possible. So it could go... It cannot go all the way up here because then that would block off the light region. Cannot go... Same thing for here. Cannot block off pink. It could go 1, 2, 3, 4, 5, 6, 7, 8, and 9, potentially. So light cannot block off the green fully. So cannot go to here, because that would block off the green fully. So I think light sort of has to go this way. This could go medium, though. Light has to extend out this way. So this can't be medium. This is light. It could connect to either of those two. So this has to be medium extended out. So medium could go all the way over here, then to here. Then to any of these, supposedly. Cannot block off light, though. So light could go here, though. Could go here, but cannot go to here. Because that would block... Well, pink could do something like that. No, it can't. Pink has to get to here. 1, 2, 3, 4, 5. There's only one of these can be pink. So 1, 2, 3, 4, 5. 6. 7, 8. And then one of these is 9. So I think this has to be pink, at least. Can this be orange? So we have... It can't be orange, because then this pink doesn't have a full region. So light can go this way, cannot block off medium. So this is all medium here. Interesting. This has to be orange then. Because dark can't be here because this is already a boundary of 2. Which accounts. And medium can't get there. Light can't get there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So light could go all the way there. 2, 3, 4, 5, 6, 7, 8, 9. So this is definitely boundary here. The thing is, we're guaranteed 3 greens here somewhere, right? That means the green has to pop up here, which means the medium has to get, or the light has to get over here, period. Because there are 3 guaranteed here, you can only have 1 pink here. Pink cannot block off light. So it can never get to any of these cells, because then this would be too many cells there. Only one of these is light, so... Well, one of them has to be light, that's interesting, but it could be just that way, so that's fine. I think this has to be pink, right? If this is not pink, then this... Where is the 9-cell pink region? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But then green would only have access to 8 cells. So this has to be pink here. So that's pink. One of these two is pink, then. So this is pink, which means this is a border. This has to be orange, so this cannot be orange here. We have 6 mediums. Say this was medium, it closed off. I think it would close off too much, right? If this is medium, and the same thing with this, right? This is medium. How many cells? You would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 cells for 2 regions, which is not allowed. So this cannot be medium. This can't be medium for the same reason. So these are both lights. Interesting. This sees at most 4 cells. for the pink region. So this cannot be 6 or 8. This sees at least 4 cells in the light region. So this is at least 4. Huh. Okay. 5, 6, 7. So say this was 2. That means only one of these would be pink. So you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. That wouldn't work. If we try to go this way, the problem is that would be too many, there would be not enough pink cells. So 1, 2, 3, 4, 5, 6, then 1, 7, and then 8, and we don't have enough pink cells, right? Because this only sees 2 in that case. So this cannot be 2. So this is 3 or 4, which means this is 6 or 8 to be next to it. It's probably 3 and 6 then, would be my guess. Hmm. Say this was 4. This would be 8, and that would be impossible. Because this light region cannot see these 2 cells, so this must be 6. So this is 6, this is 3. That means this cannot be 3 in... We have a 1, 5, 7, 8, 9 quintuplet in column 5, which eliminates 1, 5, 7, 8, 9 in the rest of the column. So this is 2 or 4. This is 2 or 4. 4 can be in a 1 to 2 ratio with 2. It can be consecutive with 5. 2 here doesn't work with anything there. 2 can only be in a 1 to 2 ratio with 1 and 4. It's consecutive with only 1 and 3. So this has to be 4 here, which makes this 2. So 4 is in a 1 to 2 ratio with 2 or 8. And it's consecutive with 5 or 3. So this is 4, this is 2 or 5. 4 cannot be here or here because of 4 in the row. This 5 eliminates 5 here in the orange region, so this is 2. That eliminates 2 here. And 2 here. Pink needs access to a 2. So does green. So does light, but light is broader. So 6 is here, which eliminates 6 here. So this must see... This sees 4 here. It has to see that this is light, at least. So that's 5, and then either this is light or this is light. So we have 5 here, 6, 7. One of these is 8. No 6 here. No 5 here because of 5 in the region. Pink has a 3, so these cannot be 3 anymore. We have a 1, 5, 6, 7, 9 sextuplet in row 6 then, which eliminates 1, 5, 6, 7, 9 in the rest of the row. 6, 7, 8, 9, sorry. So this cannot be 1. This is 3, that makes this 1. So that eliminates 1 here, no 1 here, no 1 here. This sees 3. It could be pink, 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 pink. Wait, that would be 4. 1, 2, 3, 4, 5. 6. And then 2 more. 7, 8. So this can never be pink. If that were pink, the problem is it would get too far that way. This is at least 6. These can't be medium, so this must be medium here. Cannot be dark. Hmm. 2 cannot be here for pink. So we have dark yellow. We need 1 for blue. We need 1 for pink. 2 can't be here. What are the remaining digits? 1, 3, 4, 7, 8, 9, 6. No 6 here, no 3 here. 1 is only consecutive or in a 1-to-2 ratio with 2, so this can't be 1. 2 cannot be here. We are guaranteed a 2 here, a 2 here, and a 2 here. Okay, so that's green, pink, and light. Okay. Remaining digits in row. Green needs access to a 3. Cannot be 3 here. Can't be 3 here. Can't be 3 any of these spots, so this must be 3 here as the green. Three is consecutive with 2 or 4. And is a 1-to-2 ratio with 6. So that's fine. 3 eliminates 3 here. This can't be 3 because of 3 in the row. Remaining digits in row 4 are 1, 5, 6, 7, 8, 9. Okay. This can't be 5 or 6 because of 5 or 6 in the column. Okay, so you can't go pink, pink, pink here, because then this cannot orthogonally connect to the rest of these cells, because that's already the 3 cells it sees orthogonally. So you can't go pink here. So this is medium or dark. Again, you can't have a 2x2 area that's all the same region. Oh, that's interesting. It could be green, green, green there. Okay, if this is... Okay, so if this is light, the problem is this couldn't be light here. So the light has to connect out. It would have to connect out this way, and this 2x2 area would be all light. So this cannot be light. This is green. So this must be going to light here. This is C6. This cannot be light because we have a 2x2 area that has 3 lights in it. So this can't be light. That's green. So this is done as a region. This is done as a region. It's C6. So this cannot be light. So one of these two was light. Okay, so this is done as a region. That's 7. You can't go down here as medium. This can't be green because of the 2x2 area that has 3 green, so this is pink. Green has 1, 2, 3, 4, 5, 6, 7, 8, so it must connect out here, so that's green. The light still has to have an access. I guess technically this could be light? Why can't that be light? I don't know. Pink has to connect out this way. Okay, so say this was pink. One of these is guaranteed to be light because we have only 8 lights right now. So green is done as a region. So this cannot be green. We have 1, 2, 3, 4, 5, 6, 7. One of these has to be light, so both cannot be pink. So therefore this must be pink. This is a 2x2 region that has 3 pinks. This can't be pink, that's light. Therefore this forces this to be pink left. So that's done as a region. Orange has to go out there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is orange. So that's done as a region. We have 1, 2, 3, 4, 5, 6. If we tried to go medium here, this 2x2 area would be all dark, which is not allowed. So this cannot be medium. This has to be dark, which means it connects out, so it must connect out this way. These are all dark. This cannot be dark. So these are all the regions then. Okay. Let's just check. This 6 sees 6 cells. 2 eliminates 2 here. 4 eliminates 4 here, so this is 2, which eliminates 2 here. And this can't be 2. So this sees 6 cells in the region. This sees 3. This sees 3. This sees 6. This sees 4, 2, 4, 3, 6, 6, 5, 6, 7, 8, 4. This sees 1, 2, 3, 4, 5. This sees 2. This sees 4. And those are all the light and white and black Kropki dots. Okay. We are guaranteed a 2 here. If the 2 were here... Okay, so 2 could be either of these spots. Interesting. Okay, so this sees... We have to go through each one to see how many cells... Okay, so 9 cannot be in any of these cells unless it's next to a Kropki dot. So 9 can be here, here, or here. Cannot be here. Cannot be here. Because, again, in a dot it's a Kropki knot, cells not on Kropki dots can never count the number of cells they see orthogonally in the same way. So 9 could be here or 9 could be here. If this were 9, this would have to be consecutive with 8, which is not possible, so this can't be 9 either. Okay, this cannot see 8 cells. So 8 cannot be here. This sees 3, that's fine. This could see 2. Okay, remaining digits in row 1 could be a lot of things. 1, 3, 4, 5, 6, 7, 8, 9. 9 cannot be here. No 3, 5, or 6 there. That could be everything. Remaining digits in the light region, we have 1, 2, 4, 5, 7, 8, 9. No 2 here and here, obviously. These digits are consecutive or in 1 to 2 ratios here. Remaining digit here. 1, 2, 4, 7, 8, 9. This can't be 5 because of 5 in the column. Okay, so ratios. So 3 could be in a 1 to 2 ratio with 6. 4 could be consecutive with 5. 6 can be consecutive with 5 or 7. 7 can be consecutive with 6. 8 can be consecutive with 7 or 9. So those all work. Here. 1 cannot be either of these. 1 is only next to a 2 and next to a Kropki dot. So 1 cannot be here either. If this is 1, that would force this to be 2. If this is 1, that would force this to be 2. Everything else seems fine here. All right. We know 4 is one of these 3 cells. That's not that helpful. If this were an 8, that would mean this could never be 8 and 9, so there would be no 9. These can't be 9 because of... Yeah, there would be no 9 possible then in row 1, which is not allowed. So this can't be 8. That's not helpful. Okay, how many? Okay, so let's go through. This sees 9, 9, 9, 9, 9, 9, 9. This sees 2, 3, 1, 2, 3, 4, 5, 5, 4, 4, 4. Sorry, 5. So we know in column 9, where is the 9? It has to be one of these 4 cells, which eliminates 9 in the rest of the dark region. So there's no 9 here. Where is 3 in the dark region? It must be one of these 2 cells here. Okay. Where's 6 in the dark region? Can't be here because of 6 in the row. Can't be here because of 6 in the column. Can't be here because of 6 in the row, so it has to be here. So this is 6, which eliminates 6 in the rest of the column and row. So this cannot be 6. Okay. Where is 6 in the pink region? Cannot be here, can't be any of these, so it must be one of these 2, which eliminates 6 in the rest of the column. So this can't be 6 here. Where is 6 in the orange region? This can't be 5 because of 5 in the orange region. So this must be 6 here. Where is 4 in the orange region? It's one of these 2, which means this can't be 4 because it sees both of those cells. So where is the 4 in the dark region? Can't be here, can't be here anymore. So it must be one of these 2 cells, which eliminates 4 in the rest of the light region. So where is the 4 in the light region then? Can't be here, can't be here. It must be here. So this is 4, which eliminates 4 in the rest of the column. This can't be, and row. So that means this can't be 4 anymore. Where is the 4 in the orange region? It's here. So this is 4. It's consecutive with 5, and it's in a 1 to 2 ratio with 8. So this is 5 or 8. Same with this. This is 5 or 8. 4 is in a 1 to 2 ratio with 2. It's not consecutive with 7 or 9, so this is 2 or 8 here. Where is the 6 then in the pink region? Cannot be here anymore, can't be here, it must be here. So this is 6. We have 4, 5, 6, 7, 8. We have 8 6s. So we know where the 9th 6 has to be. It has to be here. Where's the 9 then in row 1? It has to be next to a Kropki dot. So this is 9, which is only consecutive with 8. 8 eliminates 8 here, so this is 5. 9 eliminates 9 here, so it's 7. This can't be 7, that's 9. So 9 cannot be here anymore, cannot be here. This can't be 7, 8, or 9, it's 1. This can't be 1, 7, 8, or 9, it's 3, which eliminates 3 here. This 1 eliminates 1 in the rest of the red region. So this is a 5, 7, 8 triplet, which eliminates 5, 7, 8 in the rest of the red region. So this is 9, and eliminates 5, 7, 8 in the rest of the column. So this is 1. So we can't have 1 here. We have a 7, 8, 9 triplet in column 7, which eliminates 7, 8, 9 in the rest of the region. This can't be 7, 8, or 9, cannot be 4, so it must be 3. This can't be 3, 4, 7, or 8, so this is 1. That eliminates 1 in the rest of the dark region, which means we have a 7, 8, 9 triplet in the dark region and column 9, which eliminates 7, 8, 9 in the rest of the dark region. This can't be 8, this is 5. This can't be 7, 8, 9, it's 3. This can't be 5, 7, 8, it's 4. That leaves this digit as a 1 here. This cannot be 4, 5, or 6. This is 7 or 8. No 1 here, no 1 here, no 1 here. We have a 5, 7, 8 triplet in row 1, which eliminates 5, 7, 8 in the rest of the row. This can't be 7 or 8, it's 4. There's no more 8 in the light region. We can't have 1 in row 2, so we have a 2, 5, 7, 9 triplet, or quadruplet in the light region, so this can't be 5, 7, or 9, it's 1, which eliminates 1 in the rest of the column, rest of the row. Where is the 1 in the green region? It can only be here. So this is 1 here, which eliminates 1 from being here and here. This can't be 5 anymore because of 5 in the pink region. So where does that leave 1 in the pink region? It has to be here. So this is 1. That gives us all the 1s here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 eliminates 9 in the rest of column 3 and row 7. I'm going to pause. I need to go to the bathroom right now. I'll be right back. And I'm back. Sorry. When your body tells you you need to go to the bathroom, you need to go to the bathroom. So, let's continue. Where were we? Okay. 2, 7, and 8. We have a 7, 8, 9 triplet in row 3, which eliminates 7, 8, 9 in the rest of the row. This can't be 7 or 8 or 9. It's 2, which forces this to be 5. 2 eliminates 2 here, so it's 7, which eliminates 7 here, so it's 8. That forces this to be 2 here, and this is a 5, 9 pair here. We have a 7, 9 pair in column 6, which eliminates 7, 9 in the rest of the column. This can't be 9. This is 5, which makes this not 5, so that's 9. Okay. This 5 in the green region eliminates 5 in column 2. So this can't be 5. Where's 5 in the medium gray region? It has to be here. This can't be 5 or 9 because of 5 or 9 in the column. That makes a 7, 8, 7, 8 pair, which eliminates 7, 8 in the rest of the green region. So this is 9. This can't be 9 here. We have a 7, 8, 7, 8 pair in row 6, which eliminates 7, 8 in the rest of the row. So this can't be 7 or 8, it's 9. This can't be 7 or 8, it's 5. 9 eliminates 9 in the rest of column 7. And the orange region, so this is 7 or 8. This 8 here in the pink region eliminates 8 in the rest of the pink region, so this is 7, which eliminates 7 here, so it's 8 and 7, which eliminates 7 here, so it's 8, which makes this not 8, that's 7, this can't be 7 or 8, it's 9. So there's no 9 here, there's no 9 here. This can't be 8 because of 8 in the row, so this is 7, which makes this 8. 7 eliminates 7 here, so it's 9, which eliminates 9 here, so it's 7, which eliminates 7 here, so it's 8. This can't be 8 or 7, so that's 9. This 8 here eliminates 8 here, so it's 7, which makes this 8, which makes this 7. That would make that 8. Should we go through and make sure that each of the non-Kropki dots do not see that amount of cells? So this sees 9, 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 this sees 8, this sees 6, 6, 7, well, it doesn't matter, it's a Kropki dot. This sees 6, this sees 3, that's a Kropki dot. This sees 4, this sees 2, this sees 3, this sees 6, 4, 4, 4. So that's for the dark region. Green region, this sees 4, this sees 3, this sees 1, 2, 3, 4, 5. This sees, okay, so that's the correct one. These see 4. Pink region, this sees 2, this sees 3, this sees 5, this sees 3, 3. Orange region, this sees 2, this sees 4, this sees 1, 2, 3, 4, 5, 6, this sees 4, this, and these are next to Kropki dots. Red region, this sees 3 here, this sees 6, this sees 4, 4. These are all Kropki dots. Yellow region, this sees 2, 5, 5, 4. So that's fine. Blue region, these see 6, this sees 9, these see 4. So this should be an 8. And that should finish it off. Gee, Officer Kropki, crop you! Okay, so that's the ending of Officer Kropki as a puzzle, as a song. And that's the solve. Yeah, it's fairly straightforward. Yeah, I wish the rules had been a little bit clearer in what does it mean to see another cell, but that's fine, I guess. I wasn't completely certain that it was, but I was assuming it is because that's the normal definition of what it means to see another cell. So anyways, I hope you enjoyed this solve, and especially with Officer Kropki. And I'll see you next time on Frank Puzzles. Take care.